Awesome. Today, as you could have guessed from the conversation, we are going to be discussing Agentic RAG. As Daniel said, he's built a lot of systems, so I'm excited that you're here. Some quick introductions on our side. My name is Kevin. I'm on the go-to-market team here at Unstructured, based in Denver, Colorado. Daniel is a principal solutions architect. Daniel, did you change the slide? I still see the first one.
Um, Sorry. There you go.
Oh, there we are. There are our lovely faces. Principal solutions architect based in Austin. The agenda for today's conversation, a little bit of background on Unstructured. What's the problem that we solve? What is Agentic RAG? The RAG spectrum from routers to autonomous swarms. Very love that title, Daniel. How to implement a RAG system with a demo. And then we will conclude with a quick Q&A. Before we dive in, some housekeeping items. Make sure that chat goes in the chat box. If you have specific questions, there's a different tab titled Q&A. It's easier to organize and it'll help us get to them at the end of the conversation. We will send a recap of the webinar and an email with resources to get started. And if you are interested in learning more about Unstructured or have a use case you want to talk through, go to our website, schedule a call. We are always happy to chat. Awesome. Some background on Unstructured. We started 3 years ago as an open source library looking to answer the question, do companies struggle to take unstructured documents and convert them into a structured JSON output? You flash forward to today, and it's been a really incredible ride. We have tons of amazing customers. We have 50 million product downloads for our open source, and we have amazing partners like Menlo, Madrona, and IBM helping us solve this problem at scale. And without further ado, Daniel, what is Agentic RAG?
Thanks, Kevin, for that great introduction. Agentic RAG has exploded in popularity over the last year and change. And today we're going to discuss why that is, what Agentic RAG is, what problems does it solve, and ultimately how to implement an Agentic RAG system. So to start things off, let's make sure everyone in the audience is all on the same page by first answering the question, what is RAG? And what problem does it solve? And more importantly for this talk, what problems doesn't it solve? So with that, let's start with the problem statement that RAG solves for. And that is, off-the-shelf large language models are inherently static, which means they are limited by their training data, which immediately becomes stale after training and can in some cases be even years out of date. Plus, they lack access to your private or real-time information. Consequently, when asked specific questions, they often provide outdated answers, or if the question refers to something outside its training data, it often hallucinates incorrect facts in order just to answer the question. So RAG solves for this problem by combining large language models with real-time retrieval from external data sources to provide grounded, up-to-date, verifiable responses. And as you can see, an example of that with this comic, if a chatbot's pre-training data cut off in, let's say, June of 2023, it would still think that Twitter exists as Twitter with its iconic bluebird logo. But if that same chatbot were connected to, let's say, a RAG system over Wikipedia, it would know that Twitter is now X. So that's the basic idea. You combine an LLM-based chatbot or agent to a RAG-enabled knowledge source, and now you can ensure that your system always has up-to-date information. Okay, so that's the problem that RAG solves for. Now let's take a quick look at what a basic RAG system looks like. So this will be helpful later when we look at the architecture of an agentic RAG system to see how they compare. So a RAG system basically consists of 3 steps. It all starts with indexing your data. This is typically considered an offline step because it needs to happen in bulk, typically prior to the system coming online. And what does it mean to index your data? This step involves taking all of your documents that you want to make available to the system, which can even include audio and video files as well, breaking them up into roughly even-sized chunks, converting them into vectors, and storing them in a vector database. The basic idea behind RAG is that it enables semantic search over a document corpus using the power of text embeddings, which are, in turn, meaningful mathematical vector representations of words or sequence of words in high-dimensional geometric space. So once we have these vector representations of these sequences of words, it means we can do all sorts of interesting vector math on them. And comparing 2 vectors is actually the basis of semantic search, which is the central idea of a RAG system. So this actually takes us to our second step, the query and retrieval process, where we take a user query, convert it into a vector, and then query all the vectors in the vector database to find related chunks. And finally, that's followed by the third step in our process, the generation step, where we take those top-ranked retrieved chunks from the retrieval step and inject them into a prompt template, usually something along the lines of, using these chunks, answer the user's question. And then that in turn gets into an LLM where a response is generated to the user's query. Okay, so that's your basic RAG system in a nutshell, and it generally works pretty well. But if RAG is so great, then why do we need agentic RAG? So for starters, basic RAG has never been perfect. It has some intrinsic limitations, which we'll cover in one of the following slides. But there's also another arguably more important trend happening today that helps to explain the need for agentic RAG. And that is our expectations for what these systems should be able to achieve has increased dramatically. In 2022 and 2023, we were amazed, infatuated with ChatGPT. And yet it could barely even get through a whole paragraph without hallucinating something or else saying something just kind of weird or random. And today, it's nearly smarter than most people and can basically do almost anything. Yet when it doesn't do exactly what we ask, we find ourselves thinking ill of it. Like, what is wrong with you, ChatGPT? I just want you to do this simple task. What are you doing? Here's a little comic I came up with to illustrate that point. Whereas in 2023, we were stoked that AI could write a birthday card for us. Now in 2026, we get frustrated when it can't one shot make a fully featured Slack clone for us. So because our expectation for these systems has skyrocketed, what it means is that there's a growing demand that these systems should be able to answer increasingly difficult questions. So what kind of questions might those be? Let's take a look at a few examples. So let's take this first example. Let's say your organization has an internal software infrastructure chatbot. It's going to inevitably get questions like this. We are seeing a 15% spike in transaction failed errors on iOS since Tuesday. Is this related to the recent payment gateway API update, or could this be because of the iOS 18.2 rollout? Check the logs, iOS developer forums, and recent Jira tickets. So these aren't just simple ask a question, find a fact, use that fact to answer the question type of problems anymore that RAG was designed to solve. The expectation of modern AI enterprise systems is that they should be able to ask basically any question or solve any task that we throw at it, even if that involves complex, long-running objectives and all the data retrieval tasks that come with it. So basic RAG by itself just isn't cut out to solve that problem. Why? Well, it's constrained by its architecture. As enterprise queries shift from simple fact retrieval to complex multi-step problem solving, the static closed-loop architecture of naive RAG hits a performance ceiling. So the first reason is that the linear single-pass limitation of naive RAG means it really only has one shot to get the task right. So it's a rigid pipeline by design. It retrieves, then it generates. If that first retrieval step fails to return relevant data, that means the system has no way to recover. Second, the inability to handle multi-step tasks. Complex business questions often require breaking a problem into subtasks and then solving those subtasks first. Because naive RAG lacks a planning layer, it treats every request as a simple semantic search lookup, and then it fails to synthesize information across multiple documents. There's also this static data gap. These systems only read from relatively static vector stores. They can't execute tools, query live SQL databases, or verify facts against an external API. And finally, there's the absence of validation. So without a self-reflection mechanism or system two thinking, naive RAG cannot critique its own output. It blindly trusts whatever it retrieves, whereas an agentic system, as we'll see in a moment, can not only reflect on the relevance and quality of the information it retrieves, but it can self-correct and iterate until it believes it has arrived at an answer that is both valid and accurate. So it's for all of these reasons that we need something like agentic RAG. So without further ado, let's jump into the focus of today's talk, unlocking your data with agentic RAG. So coming back to what is agentic RAG, just as the name suggests, it is the intersection of AI agents and RAG. Plus, while formally that's it, in practice, because of the flexibility of AI agents and their architecture, the system almost invariably also sort of sprawls to include other data retrieval tools in your stack as well, such as API calls, database queries, and so forth. So in any case, the big shift here is that it transcends the linear pipeline. So we're now embedding retrieval within an autonomous cognitive control loop. In this paradigm, the LLM isn't just a text generator, it's actually the orchestrator and reasoning engine behind the whole system. And because it has something approaching true agency, the system can do things like plan and decompose tasks into subtasks. It also has the autonomy to choose the right tool for the job, possibly searching across disparate data sources. And finally, it can evaluate its progress, refine its approach, and iterate. This is the big one because if the first path fails, it doesn't just fail as a full system. It regroups, tries a different path, or adjusts its approach until it either gets it right or exhaustively determines that the information isn't available enough to solve the problem. So to visualize this shift, let's look at the actual architecture. So here is what the autonomous cognitive control loop looks like in practice. And if you're familiar with agent systems, this will probably look familiar. And also, if you remember the RAG system diagram that we saw at the beginning of the talk, I've actually shrunk it down and moved it into its respective location here as a vector search tool made available to an agentic RAG agent. So here we've moved away from the linear flow and placed the agent, the LLM, at the center as the orchestrator. And there's four key pillars here to making this all work. So there's the three boxes here connected to the agent. First, you have planning and reflection. This is where the system uses self-criticism to check its own work and revise its strategy if necessary. Then you have memory, both long-term and short-term, where it stores data so it doesn't repeat mistakes. And finally, it has tools. This is the agent's utility belt. This is where it can connect to external systems and take action so that it can choose between vector searches, web searches, APIs, depending on the task. And then plus the fourth pillar is the agent actually has the ability to choose among these options and choose how many times it goes through each action as well. So that's represented by the arrows here. Those arrows are representing the control loop where it goes through different reasoning cycles, planning, executing, reflecting, and then iterating until the goal is met. So this is the engine that drives reliable, complex problem solving through an agentic RAG system. But not all agentic systems are created equal. There's actually quite a range of how much autonomy we can give these loops. And it's important to realize that agentic RAG isn't a single toggle switch. It's actually a spectrum of capability, which comes, of course, with corresponding complexity. Of course, these levels all borrow heavily from established agentic design patterns, so you'll probably recognize them. And some of you might even recognize some of the first ones here, at least, such as the router pattern from the very early days of LangChain and flow programming, which it's actually been around since then. So depending on your use case, you might land anywhere on this scale. The router pattern, as you can see here at level 1, is the simplest. It's basically where you classify incoming requests and then you route them to specified data sources that correspond with those classification rules. So whether it should go to the SQL database or whether it should go to your vector index. Level 2 is where we actually introduce the basic loop. This is actually typically called corrective RAG, where it basically adds a quality control step by grading the retrieval results and then rewriting queries if the initial results don't really measure up. Level 3 is where we actually get into sort of a name that lives up to the agentic RAG title, in that the system is actually endowed with what would be considered much closer to true agency, where it can actually choose its path through this maze. It can actually go through the planning steps. This is typically characterized by what's been coined the REACT pattern, which is the reasoning plus action, where it basically is a multi-step reasoning loop where it goes through the iterations of thinking, acting, observing, and then it cycles through those in order to solve complex tasks. And then finally, level 4, this is where you get into full-blown multi-agent systems, a multi-agent swarm. This is the high end of the spectrum, and this is basically, it involves orchestrating multiple specialized agents for long horizon tasks. So as you move up the spectrum, of course, the power increases, but of course, also so does the complexity of the build. So it's important to weigh the trade-offs between capability and complexity for your given use case. Okay, so now that we understand what an agentic system is in a nutshell, how do we actually go about implementing an agentic RAG system? So this slide is our big picture view of the entire landscape. Credit for this graphic goes to an archive paper that came out last year surveying the agentic RAG field. If it looks a bit busy, that's because Agentic RAG is, as I mentioned before, the intersection of two pretty massive disciplines, the science of building robust RAG and data retrieval systems, combined with the art of building agentic systems. And at the top, you can see here the framework and stack portion. This is for selecting the agent portion of the system. Whether you're using LangGraph or Google's Agent Development Kit or any of these, or even your own homegrown framework, the framework doesn't matter so much, but it's an important building block for the overall system. But the real power lies in the middle column, the agentic design patterns. And this is where we're taking those RAG foundations like modular RAG or graph RAG, and we're wrapping them in sophisticated workflows like evaluator optimizer loops or orchestrator worker models. If you look at the taxonomy on the right here, you'll see a variety of strategies available, from a simple single router, as we discussed previously, all the way up to some specialized approaches such as Agent G or Gear, which is where you actually combine GraphRag with more traditional vector search, and it's about how to synthesize those. So especially these bottom ones, they're just really tried and true approaches for how to architect an agentic RAG system that retrieves and synthesizes data from multiple different sources. So the goal here isn't just to add an agent into the mix, but rather to thoughtfully understand the agentic design patterns available and choose the specific pattern that unlocks the capabilities desired by your organization or your customers. So here we have the design patterns, the tools. We have a working agentic RAG taxonomy. That's again, this box in the bottom right, for how to build an agentic RAG system. But how do we actually start building? So to answer that, let's jump into our agentic RAG crash course, where we'll break down the actual process for implementation. So if you're looking for a rough roadmap to get started, this is a good high-level process, and we can basically break it down into 5 key steps. Step 1, you define the orchestration and toolset. So you start by selecting an agent framework and a reasoning-enabled LLM. You then equip your agent with a utility belt of tools. This is going to be things where you define your vector database access, whether you want to give it access to web search APIs or even specialized tools such as calculators to extend its capabilities. Step 2, you really need to implement query decomposition. So this is where you take the incoming request and you decompose it so that it can basically be executed in a series of subtasks. Step 3, dynamic retrieval and self-correction. So stop relying on a single top K retrieval pass, such as in a basic RAG system. This is where you configure your agent to evaluate the results. If the data is garbage, then it should have the autonomy to self-correct and try a new strategy. Step 4, this is where you introduce the react pattern. This is basically where the agent logs a thought, takes an action, observes the result, and repeats that cycle until it hits a confidence threshold. And this is often where you invoke memory as well. And step 5, evaluation and guardrails. You're going to want to set guardrails like recursion limits and token budgets so that your agent doesn't just get stuck in an expensive infinite loop, from which it can't break out of. And of course, if you want to actually measure things like the success of the framework, you might want to use a framework like Ragus or TrueLens, basically just for that extra validity. So to make this all more concrete, let's actually walk through an illustrative example of this loop in action. So looking at a concrete example of this, let's take a financial advisor agent that's trying to answer this complex portfolio question, as you can see at the top here. So given my 100K portfolio and moderate risk profile, should I liquidate my tech holdings to invest in the emerging solid state battery sector based on our latest analyst research? So you can see this is not a simple RAG question. This needs to be broken down. It needs to be decomposed. A strategy needs to be formed. Multiple data sources need to be called. And in order to solve a problem like this, we're going to need a system like an agentic RAG system. So step 1, if we go back to our steps from the previous slide, this is where we're going to define our orchestration and tool set. So this is where we'd choose our agentic framework. Let's say we decide to use something like LangGraph. We then give the agent its toolkit. So for this financial use case, we're going to equip it with a market research vector search, a live stock price API, and a risk simulation tool. Step 2, we're going to implement query decomposition. This will typically get handled in sort of the agent's core identity. But basically, this is where you want to decompose the query into something like this. So this, as you can see here, it's not actually the prompt to decompose it. It's what the results of that decomposition should look like. So in this case, we're having it break it down to a SQL query, a vector search query, and an API call. Step three, dynamic retrieval and self-correction. If the vector search returns conflicting reports, like one report says buy and one report says sell, the agent doesn't just average them. It can actually self-correct by looking up more information to sort of weigh those different competing results. So it can maybe look up the historical accuracy of the analysts that prioritize or that made those reports in order to prioritize the most reliable data. Okay, step four. This is where we introduce the multi-step reasoning, the React pattern. So it's going to enter into a reasoning and action loop. This is where it thinks the research looks volatile, so it takes actions of using the risk simulation tool to see if the trade actually fits with the user's specific risk profile. And step five, evaluation and guardrails. We might want to here implement loop caps. For example, let's say a maximum of 5 tool calls to prevent runaway costs, or maybe 10 tool calls. And then this is also where we can introduce some frameworks to ensure that the final answer is faithful to the data. You can use gold standard data for sort of measuring against a baseline, or however you want to set it up. So to show you how to simplify basically in a nutshell, that's how this system, an agentic RAG system will work. It's really just, if you're familiar with agentic design patterns, it's really just building an agent system and then wrapping your vector indexes in a tool call, and then having some sort of way to measure the results. And of course, using all those agentic design principles to basically balance the behavior of the agent internally. So to simplify the foundation of actually how to build the RAG portion of the system, we're going to jump to a quick demo. And so the unstructured platform makes that RAG step of building your vector indexes very, very easy. So to demonstrate that, I'm just going to pop open this is our SaaS-based portal, and it basically enables sort of no-code, set it and forget it RAG pipelines. And building them becomes very, very easy. So we'll take a quick example of that. I'm just going to pop open a document. So imagine that you're a real estate company, you have tons of these documents, tons of house listings, and you want to build a RAG system over this. So that can be very difficult, especially with all the different images. How do you actually describe the images of these different properties? So using the unstructured platform, we can process all this automatically. You can see on the right, this is the transformed output. I'm going to go ahead and update the results here. And you can see if you actually click on the JSON here, you can actually see descriptions of these images. And there's a lot involved with the transformation. And we can go from this simple pipeline to actually building a full-blown RAG system over this just by clicking that little button as I just did. And then all you need to do to actually convert it into a RAG system is hit this add chunker button, and then we need to add an embedding step. And just like that, we've actually built a full-blown RAG system. So I'm going to label it as such, basic RAG system. And if we save that, you can actually go ahead and set it up on a schedule as well. You can have it run daily. You can have it run at a certain time of month. We can hit save. And just like that, we've built a RAG system. So that is sort of the power of the unstructured platform. And it is basically crucial if you want to be building agentic RAG systems to have that sort of firm foundation, similar to how you would choose an agentic framework. Choosing a RAG framework like Unstructured will very much simplify your process. So to wrap things up, let's hit the high points of what we covered today. First, we defined agentic RAG as the shift from a linear one-shot pipeline into an autonomous cognitive control loop where the LLM acts as the orchestrator. We also looked into what problems RAG solves, the agentic sort of agency spectrum, as well as how to implement an agentic RAG system. And finally, I showed a demo of the unstructured platform, which is great for building sort of the RAG portion of these systems. If you enjoyed today's webinar, we have a lot of great other webinars in our archives. You can check any of them out from our website, and also be sure to register and tune in to our next webinar on benchmarking Gen AI data pipelines for enterprise. And with that, we don't have much time, but we might be able to squeeze in one question or two.
Awesome. Daniel, thank you so much. That was exceptional. Okay, so jumping into questions, Scott wants to know, is there a way to just connect data from many sources and not worry about the transform quality of the data? Absolutely, Scott. That's exactly why we exist. So we support most enterprise sources, and then baked into our platform is this auto router, which will route documents to the appropriate parser based on document type and document complexity. And if there are specific data types that you're struggling with, reach out. We'd love to, work through this problem with you. Second question, I realize we have probably 30 seconds. Daniel, speed run. How do you debug agentic behavior by just making multiple tool calls? Sorry, I picked a
Yes.
tough question for you. Super quick.
No, it's great. So I sort of touched on it, but with any sort of agentic system, you really want to be logging every sort of like action that the agent takes using something called traces, and that can actually be sent to like Phoenix or Rise is a great tool that I often use, or any sort of observability tool. But the key word there is traces, and then that way you can actually debug all the different paths that the agent is going down.
Awesome. All right. We are coming up on the end. I just want to thank everyone for being here. For the other questions, I see Joshua just asked. We'll respond in over email to specific questions, but thank you for being here. We'll be back in 2 weeks to talk about benchmarking and evals on ingestion and preprocessing. And we really hope to see everyone there. Bye, y'all.